Today we are going to talk about the internal structure of ponds, right? And after that we will discuss the liens of the ponds, right? So first of all, internal structure of the ponds. Let's put the things in perspective. You will rapidly tell me. I'm going to make, what is this? Brain stem, very good. And inferior pontine sulcus, superior pontine sulcus, and this is the pons in between, right? As you remember that how the nerves are attached there, right? Here is which nerve? Yes, sixth nerve. On the side there is, yes, seventh, and on lateral most there is eighth. And here in the mid-pontine position, which nerve system is there? 5. Now look, why I started lecture from here? Because you must know that the internal structure of the pons at lower level must have nuclei related with 6th, 7th and 8th. Is that right? It's very logical that if we make a section at lower level of pons, right, we should be able to see the nuclei related with the 6th nerve, 7th nerve and 8th nerve. It means the abducent nucleus should be there, facial nerve related nucleus should be there, and vestibular nuclei and cochlear nuclei should be there, right? And of course, when we make a section in the pons at upper level, what should disappear? If we make section at the mid-pontine level, what should disappear? There should not be 6th, there should not be 6th nerve nucleus, abducent, there should not be the nuclei related with the 7th, and there should not be vestibular and cochlear nucleus. At mid-pontine, there should be nucleus of related with trigeminal system, especially trigeminal nerve motor nucleus and principal sensory nucleus of trigeminal system. Is that right? This is first thing which you should know, that we are going to study pons by making section at lower level, which is section in the pons passing through the, you can say through 6th, 7th and 8th nerve nuclei, and then we'll make a section of pons at mid-pontine level or relatively upper level, which will be passing through, the section will be passing through nuclei, passing through the trigeminal nerve, principal sensory nucleus and motor nucleus. Any problem here? Now let me make a section at lower level, that I'm making a section here. Is that right? We are going to make a section here. Let's draw it here. Right. Now, this is the front of the pons in the section. This should be on the back of the pons. I think I should be at lower level because I can draw the two sections. Why it is not so symmetrical as it should be? Anyway, now this is the front of the pons, right? And this is back of the pons. You must be knowing on the front there is, what is this groove? Basilar groove. Is that right? And it lodges which artery? Very good. Here we can put your 4th ventricle, right? Of course, from the front of the pons, this is the front of the pons, this is the sides of the pons, and what is this going backward to the cerebellum? Middle cerebral peduncles, that's great, and this is 4th ventricle. Now, when you make a section in the pons, pons is divided into its interior part and posterior part. Interior part of the internal structure of pons is called base of the pons, right? What is that called? Base of the pons. So this is base of the pons, and on the posteriorly, this substance of the pons is called, yes, tegmentum. Tegmentum, right? Now, what is the demarcation between the base of the pons and tegmentum? The demarcation is made by special type of crisscross fibers here, and this structure is called trapezoid body. What is the structure called? Trapezoid body. What is trapezoid body? Here you find lot of horizontally crossing fibers, is that right? And it is related with the cochlear system. I will explain in 1 minute, but the substance of the pons interior to the trapezoid body is base, and trapezoid body and posterior to it, that is tegmentum of the pons. Now let's see what is trapezoid body. From where, what is the structure and function of trapezoid body? Let me make a very simple diagram related with the brainstem. Now here I am going to explain trapezoid body. Now this is the brainstem, of course, midbrain, pons, medulla. Here is your beautiful ear. Of course, you have 2 ears if you have some, right? External ear, middle ear, and then there is internal ear. Internal ear has cochlea, right? That you will learn these things in detail in the lecture on inner ear. And here is very important structure which is called vestibular apparatus. What is it called? Vestibular apparatus. Now, this vestibular apparatus is concerned with the sense of balance, and this cochlea is concerned with the hearing. Is that right? From the cochlea, the fibers which are going, sensory fibers which are taking information related with the sound towards the central nervous system, these fibers are going to the central nervous system as which nerve? Cochlear component of vestibulo-cochlear nerve. As you must be knowing that these are your vestibular fibers, and this is how vestibulo-cochlear nerve is made. Is that right? Now what is this nerve? Cochlear nerve. Cochlear nerve is bringing the, you can say, information from the inner ear about the hearing. Is that right? And cochlear nerve is of course attached at the pontomedullary junction laterally, right? Now what really happens from here, you have to understand that in the pons there are ventral cochlear nuclei and there are dorsal cochlear nuclei again. Within the, okay, I will make them with a different color so that you can appreciate that. This is ventral cochlear nuclei and these are dorsal cochlear nuclei. Here there are ventral cochlear nuclei and dorsal cochlear nuclei. When cochlear fiber come here, they divide into 2 divisions. Some of the fiber go to dorsal cochlear nucleus and others come to the ventral cochlear nucleus. Is that right? Now, from here, fibers, what is this structure? Cochlear nuclei, right? Ideally, I will make them green. These are cochlear nuclei, ventral and dorsal. Especially from ventral cochlear nuclei, many fibers go contralaterally. Right? Are you getting it? Right, contralaterally. From right cochlear right cochlear nucleus, next order neurons are moving to the opposite side. Same is true about the other side. Now, these fibers which are crossing, right, some of the fibers may be contributed by dorsal cochlear nucleus also, but dominantly ventral cochlear nucleus. From the nucleus, when fibers arise and they are moving contralaterally, they cross each other. And when they are crossing, after they have done the crossing, they are now ascending, yes, upward. These are sensory fiber. So this crisscrossing fibers here are making trapezoid body. So what is trapezoid body? Trapezoid body is mainly made of contralaterally going crisscross fibers derived mainly from ventral cochlear nuclei. Is that right? From here now look, these fibers from the trapezoid body, they are moving upward. They are going to where? To the midbrain. These are, of course, look, these are the action potential coming from the cochlear system. So the cochlear nerve going to cochlear nuclei, then crossing contralaterally in the lower part in the pons, and within the pons they are crossing as trapezoid body, and then they ascend upward. And when these fibers are going upward, they will end up into on the posterior part of the, what is it, midbrain. In the lower part of midbrain posteriorly, there is a special swelling here, and this swelling is called, yes, inferior colliculus, right? So these fibers go upward from the trapezoid body and they terminate into inferior colliculus. And of course, from there, these fibers, okay, this is nucleus of the inferior colliculus. From there, these fibers go upward towards the next order neurons, go near the, you can say, thalamus. Thalamus is here, and on the side of the thalamus there is a special structure here which is called medial geniculate body. What is this? Medial geniculate body. And of course you should not forget, as you are very intelligent, that what is this here? Hemisphere, right? Now look, auditory fibers should eventually reach to the auditory cerebral cortex. Auditory cerebral cortex is here, temporal lobe. You know that? Auditory cerebral cortex is present in temporal lobe. So actually, how the action potentials reach from cochlea up to the auditory cortex, right? First of all, action potential, sound waves eventually produce action potential in cochlear apparatus, from where information is taken into cochlear nerves, then into cochlear nuclei, then trapezoid body. From there, fibers are ascending upward. This structure and this bundle of fibers which are going upward, taking the auditory information, this bundle is called, excellent, this bundle is called lateral lemniscus. So from the trapezoid body, lateral lemniscus is going upward throughout the pons. So lateral lemniscus can appear into lower pontine section as well as in upper pontine section. Is that right? Lateral lemniscus will appear into all pontine sections, right? And it will terminate at, what is this? Nucleus of inferior colliculus. And from here, next order fibers, what are these? What is this structure? Connecting the inferior colliculus to the medial geniculate body. This is called inferior brachium. What is this called? Inferior brachium, right? And then to what is this? Medial geniculate body. From the medial geniculate body, the fibers are going, what is this? To auditory cortex, and these fibers are called, yes, auditory radiations. What are they called? Auditory radiations. Now, why I discussed this whole auditory system in relation to pontine internal structure? There is a reason for that. I don't want just to memorize it. There's lateral lemniscus, there's trapezoid body. You must know exactly what they are doing there. Is that right? So, in the lower pontine level, in the section, you will find ventral and dorsal cochlear nuclei. So, can we put these cochlear nuclei there? Right? For example, we put ventral cochlear nuclei here, cochlear nucleus here, and we can put ventral cochlear nucleus here, and dorsal cochlear nucleus here, and dorsal cochlear nucleus here. Is that right? What are these? These are our cochlear nuclei, right? And of course, fibers from here. It's not difficult to understand now. What are these fibers contributing to? Yes, please. Trapezoid body, and some of these fibers may also come, but mostly these are the ventral. Am I clear? Now, this trapezoid body can be visualized at lower pontine section, but it also can be visualized in upper pontine center. But cochlear nuclei are present only in lower pontine section. Is that right? It means some fibers are going obliquely also, so that trapezoid body can be seen in upper pontine section also. Is that right? Secondly, in pontine sections, you will find lateral lemniscus here, as well as lateral lemniscus in upper section. Another thing, there are some nuclei which are embedded within the trapezoid body, and these are called the nuclei of trapezoid body. What are these called? Nuclei of trapezoid body. And then there is a very important nucleus within the lateral lemniscus here. Lateral lemniscus fibers are going up, right? There is on the way some fibers terminate in a nucleus, and then next order neurons start from that nucleus and move upward. These nucleus, yes, who will tell me what is this structure? No, my friend, trigeminal nerve has nothing to do with the auditory system. Yes, as fibers are going upward within the lateral lemniscus, some of the fibers terminate in a nucleus, and then from that nucleus fibers are contributed further in upgoing lateral lemniscus. So what is this nucleus? You have heard of it. Have you heard of it? Superior olivary nucleus. This is exactly what is superior olivary nucleus. Superior olivary nucleus, of course everyone knows inferior olivary nucleus, which is on the lateral part of medulla. Right? I'm not talking about inferior olivary nucleus, I'm talking about superior olivary nucleus, which is present in the pons or in relation with the ascending fibers passing through what? Internal pontine. Can you magnify really please? Try to magnify things when I'm focusing, right? Yeah, so that it should become more clear. Now, so these are superior olivary nucleus which are present within the lateral lemniscus, and these nuclei are also playing a role in auditory system. Any question here? There's no. So this was something about. Now you understand what is the exact position of what are these things? Cochlear nuclei, right? And you also know what is the importance of trapezoid body, right? And from where it originates. In front of that we have base, and on the back of that we have tegmentum. Any question here? No. Now we will go and study this section into detail. First I will discuss the base into detail, and then I will discuss tegmentum into detail. Now, in the base, what is there? In the base, there are pontine nuclei. What are these? Here we have pontine nuclei. Now, let me show you exactly what pontine nuclei are doing. Pontine nuclei are present in the base of pons at upper level as well as at lower level. Is that right? These are pontine nuclei. As I told you in previous lecture that pontine nuclei are receiving which fibers? Which fibers are coming down? Cortico-pontine. And they are coming from all parts of the. And for what is this? These are all fibers which are called cortico-pontine. Cortico-pontine fibers terminate into the base of the pons at upper and lower both levels, and from there, which fibers go backward? pontocerebellar. And these fibers, when they are going backward, right, they are contributing to middle cerebral peduncle. Is that right? Now, this pathway can be drawn here, that these fibers which are coming from the top, what are these fibers? Yes, please. Corticopontine. Then from here, the fibers are crossing, right? And then they are going here. And what are these fibers, please? This is pontocerebellar. So these are the fibers which are coming down. These are corticopontine, terminating on the pontine nuclei. From then they move contralaterally, and then they are moving backward through the middle cerebral peduncle towards the cerebellum. Is that clear? So this structure makes some sense to you. Then from the motor cortex and from premotor area and supplementary motor area, there are fibers going down, and even some from other. Now these fibers which are going down, these are what are these fibers? These red fibers which are going down. Some of them will end up on motor nuclei in brainstem. Some of these red fibers will end up in the motor nuclei in the brainstem, and other fibers will come into spinal cord. I will draw the section of spinal cord. Is that right? This is front and this is the back. Now, these fibers, some of them will come, for example, this is, let's suppose this is hypoglossal nuclei. So some of these fibers which are coming from down, and they will end up into motor nuclei in the brainstem, right? And some of these fibers will come down, and these fibers will pass through the pons, base of the pons, and eventually they will reach to, what is this? Spinal cord where? Anterior horn. From where the fibers will eventually go to the muscles. These are lower motor neurons, and these fibers which are coming all the way are part of upper motor neurons. Is that right? Now, these fibers which are coming down from the cortex, right, and terminating on the motor nuclei of the brainstem, these are called corticonuclear fibers. And other fibers which are going down all the way to spinal cord and controlling the motor output, they are called corticospinal fibers. Now you can see in upper section and lower section of the pons, corticonuclear and corticospinal fibers are passing through the base of the pons. So we can say here are which fibers going down? Corticonuclear and corticospinal. Corticonuclear will end up into nuclei of the brainstem, right? Especially they are going to the medulla downward, and corticospinal are going to the spinal cord. Am I clear? So how many fibers are passing? The downgoing fibers are passing through the, what is this? Base. The corticopontine fibers which terminate at the base, the corticonuclear fiber which are on the way towards the motor nuclei in the brainstem, especially motor nuclei of the medulla, they are going down. Then corticospinal fibers which are also going down. So this is the basic structure of the base. Do you have any problem in this? No problem into that? Okay. Now what was this? This was trapezoid body. Now this was the descending fibers. Just on the back of that, there are ascending fibers. As you know, these are descending fibers, so they are part of the motor system, right? Then sensory information from all over the body is going upward. So there must be ascending tracts also passing through the pons. As there are descending tracts, there should be ascending tracts also. Now, what ascending tracts can be visualized or passing through the pons? Let me make a structure here. Let me make a section of spinal cord. Please magnify it with it, please, so that people can see. Now, what we can see, sensory fibers. Number one, the sensory fibers come here as, let's suppose, dorsal column system, which is fibers go here, and from the dorsal column they are going upward as fasciculus gracilis and fasciculus cuneatus. These fibers are going to here, nucleus gracilis and cuneatus in medulla. From there they will cross as, yes, internal arcuate fibers, and then they are going upward as, yes please, they are going upward as medial lemniscus, and this is medial lemniscus which is going upward until it reaches, yes, ventroposterolateral nucleus of, ventroposterolateral nucleus of what? Please tell me. This is thalamus, right? And from the thalamus, sensory fibers go upward through the internal capsule. You remember something like that? And eventually to the sensory cortex. Now the point which I want to make by this diagram is, now in the dorsal column, which sensations are going? In the dorsal column, the sensations which are going are, number one, vibration sense, number two, 2-point discrimination, right? We also call it tactile discrimination sense and fine touch sense. So these are, or proprioception fibers. These are dorsal column sensations. So dorsal column fibers, as they are going upward, right, as fasciculus gracilis and cuneatus, the part of medulla, by terminating into nuclei of gracilis and cuneatus system, they cross as internal arcuate fiber, and they are ascending as, what is this? Please, what is this? Medial lemniscus. So, medial lemniscal structure will be seen at cross section at lower pons as well as into upper pons, even at lower midbrain and upper midbrain. Is that right? So, there is no fun in memorizing it. Something which is passing throughout the brain stem should be there in all sections. Am I right? So, what we really see that lower pons and upper pons section, in both situations, there will be medial lemniscus. Let me draw medial lemniscus here. So, these are the fibers. Which fibers are these? This is medial lemniscus. These are upgoing fibers, isn't it? And these upgoing fibers are dorsal column modalities like vibration, 2-point discrimination, and tactile sensation and proprioception. All these are, what is this again? Medial lemniscus. Any problem up to here? So this will be present at this level as well as at upper section, right? Now, another system which is ascending is for pain and temperature and crude touch system, which is anterior and lateral spinothalamic system. Let me explain. These are the pain and temperature fiber entering into, what is this? Spinal cord. They terminate here, and from here, second order neuron cross as lateral spinothalamic and anterior. Now these are the anterior, what are these? Spinothalamic system going on, and from here we have ascending, what is this please? Lateral spinothalamic. But in the medulla, and lateral spinothalamic system and anterior spinothalamic come together, and they make this structure which is called, yes please, along with spinotactile fibers. So anterior spinothalamic tract which is bringing the crude touch, and lateral spinothalamic tracts which are bringing pain and temperature sensations, and along with spinotactile fibers and spinoradicular, right, these fibers come together in medulla and make another, what is this? System of lemniscus system, and this is called spinal lemniscus. Spinal lemniscus is moving slightly laterally to the medial lemniscus. Of course, medial has to be medial. The medial lemniscus is medially, and laterally we have spinal lemniscus. These fibers are also going up, and they are terminating into ventroposterolateral nucleus of thalamus. So now again, you will see that this spinal lemniscus will be seen in all the sections of pons and all the sections of midbrain, slightly laterally to what? medial lemniscus, right? So this was medial lemniscus. On the side here, I will put, what is it? Spinal lemniscus. What is it? Spinal lemniscus. And here I will put, what is it? Medial lemniscus. Medial lemniscus is having dorsal column modalities of sensation, and spinal lemniscus is having anterolateral modalities like pain, temperature, and crude touch. Is that right? Okay. Now, after that, if you remember that from the trapezoid body, there was lateral lemniscus going up. So, actually, here, lateral lemniscus should also be seen. What is this? Lateral lemniscus. Now, really don't put too much burden on your cerebral cortex. Medial lemniscus has to be medial and lateral lemniscus has to be lateral. And both of them are compressing in between spinal lemniscus. These are our ascending system. So, what we can see that in front in the base there was descending systems, and on the slightly posteriorly from the base in the tegmentum there are ascending system. Whenever you study a part of brainstem, you have to understand what are the fibers which are descending, what are the fibers which are going upward, that is ascending, and what are the local systems. Is that right? Of course, we know local system in lower pons is 6th nerve, 7th nerve and 8th nerve. But descending systems are cortico-spinal, cortico-nuclear and cortico-pontine, which terminate there. Ascending systems here we have seen medial lemniscus with dorsal column modalities, spinal lemniscus with anterolateral, pain, temperature, crude touch, and of course lateral most area we are having lateral lemniscus for auditory information. Any question you have here? There's no question here? Right. Now another thing. If you remember, there was something called spinocerebellar fibers and spinocerebellar tracts. You remember that? Okay. And of course, you know cerebellum should be here, isn't it? Right? And what is this? Inferior peduncle and middle cerebellar peduncle and superior cerebellar peduncles, right? Now, there was dorsal, what was there? There was dorsal spinocerebellar fibers which go upward and through the inferior peduncle, they will go to the cerebellum. So, do you think dorsal spinocerebellar tracts can be seen in two pontine sections? Dorsal spinocerebellar tracts can be seen in pontine section. Answer is no, because dorsal spinocerebellar fibers enter through the inferior cerebellar peduncle to the cerebellum. But look at your ventral, what is this? Ventral spinocerebellar fibers. What are these? Ventral spinocerebellar fiber. They go upward until they reach to the lower part of midbrain, and from there anterior or ventral spinocerebellar fiber through the superior peduncle, they enter into cerebellum. And if you really want to know, within the cerebellum they will cross on opposite sides. But right now we are not concentrating on that information. What we are learning that dorsal spinocerebellar tract enters into cerebellum through inferior cerebellar peduncle, and ventral spinocerebellar tracts eventually reaches cerebellum through superior what? Superior cerebellar peduncle. So when we are making pontine sections, which you will see? Which spinocerebellar tract? Ventral or dorsal? Ventral, isn't it? So again, here we can put that here is ventral. Okay, I will put it blue. But what is this? What is this, please? Ventral spinocerebellar tract, which is passing through the pons upward to reach to the lower part of midbrain, from where it can jump into superior cerebellar peduncle on the way to cerebellum. Any problem here? Is that clear? Right? Now we move forward. These are major descending systems and ascending systems. Let's concentrate on the local systems. Should I make this diagram again to make it more clear and see how much you have learned? Let's see it. let's see how much you have really learned. I don't want that later on I learn, I have revised it for myself. This is fourth ventricle. Here should be a depression, basilar. I hope you understand what I'm drawing. Is that right? Base of the, okay, first of all, this important landmark. What was this? Trapezoid body. You understand now, right? And in front of that, what are these nuclei? Rapido. Pontine nuclei. You are very intelligent. People have friends which are intelligent. What is this going down? Corticonuclear and corticospinal fibers. And the fibers which come and terminate here are corticopontine fibers. No problem here? Wow. So, and of course, you know, from here these fibers cross and they are going and contributing to where? Middle cerebral peduncle. Now, after this trapezoid body on the side, right, we have along with it ascending system. What is this ascending system? Medial lemniscus. Yes, please. Medial lemniscus. On the side of that, what is here? Oh, should make it green or what color? Okay. This is pressed in between. Spinal lemniscus. Right? Spinal lemniscus. On the side of that, what was going on here? Lateral lemniscus. Do you think these things are really difficult to understand? And then more laterally, we have your ventral spinocerebellar tract. So these were this was your descending system here, and here is your ascending system. Now we come to the local systems, right? In the local system, first of all, in the floor of the fourth ventricle, you must be knowing that there were two depressions here, rather elevations within the floor of fourth ventricle. Can you tell me what was these elevations? Facial colliculi. You remember that in previous lecture? Now, here there should be what? Which nucleus? Sixth, abducent nucleus. And abducent nucleus fibers are going straight out from here. Right? These are which fibers? Abducent nucleus. And what are these fibers coming from here? Of course, again, abducent nerve fibers. Is that right? Any problem here? No. Then this is a sixth nerve, and there should be a lower pontine seventh nerve system and eighth nerve. Let me put the seventh nerve system. Seventh nerve nucleus, which is the nucleus for the muscle, the facial expression, that is here. Right, look at it. It's smiling because it gives a lot of expression. This is nucleus for muscles for the facial expression. These fibers move, yes, backward, right? They move backward and then they turn around. What is this thing? Facial nerve nucleus. And what is this? These are the fibers originating from motor nucleus of facial nerve, and they move backward dorsally, you can say backward, and medially, and they move around the facial nerve. Move around the nucleus of the abducent nerve, and then they start moving forward and laterally, and eventually they go out on, what is this? These fibers going out, please? Yeah, facial nerve fibers. Which fibers of the facial nerve? Fibers going to for the innervation of muscle the facial expression. Is that right? Is it clear? No problem here. Then you must be knowing that facial nerve has more components. Facial nerve has not only fiber for the, not only the fibers from the muscles of facial expression, but facial nerve have fibers for, yes, fibers for taste fibers, for interior 2/3 of the tongue. So it means the nucleus of related with the taste should also be connected with the facial nerve. So here is the nucleus, upper part of a nucleus which is concerned with the taste. What is the name of this nucleus? Yes, tractus, nucleus of tractus solitarius, right? This nucleus collects the taste information from 7th nerve, 9th nerve and 10th nerve. So from 7th nerve, it collects the information about the taste from interior 2/3 of the tongue. Is that right? So taste fibers which are coming along the 7th nerve. Now what I am showing, taste fibers which are coming from the interior 2/3 of the tongue through the 7th nerve, they terminate into, what is this? Nucleus of tractus solitarius. These are the taste fibers, which are sensory fibers, of course. These are special somatic afferent fibers. Is that right? And these red fibers which are going to the muscles of facial expression and stapedius muscle, these are called special visceral efferent fibers. Is that right? Now, after that, you must be knowing facial nerve also have a lot of parasympathetic fibers, right? Those parasympathetic fibers are going to, yes, that is also related with expression. Lacrimation. Is that right? So there are parasympathetic fibers going to the lacrimatory system through the facial nerve. There are also parasympathetic fibers going through the facial nerve for salivation. Through the facial nerve, parasympathetic fiber goes through the submandibular ganglion to the salivary gland, sublingual salivary gland and submandibular salivary gland. So it means that facial nerve should be connected with, yes, parasympathetic supply in the brain stem. Am I clear? Right. So actually here is a special, okay, it is looking like a drop, maybe a drop of saliva or drop of your tears. Now this nucleus is parasympathetic nucleus which is supplying parasympathetic motor fibers to the facial nerve. Is that right? And these fibers, these parasympathetic fibers are eventually going to yes, they come through the facial nerve out and they are going to through the two ganglion, they will eventually go to their destination. One ganglion is pterygopalatine ganglion, other ganglion is submandibular ganglion. Through the pterygopalatine ganglion, these parasympathetic fibers eventually go to lacrimatory system, lacrimal gland, and also to some nasal glands and some glands in the palate and some in the nasopharynx. And from the submandibular ganglion, these parasympathetic fibers go to sublingual salivary gland and submandibular salivary gland. What I really wanted to tell you that within the lower section of the pons, when you see that facial nerve fibers passing through the substance of the pons, these should have how many types of fiber? Number one, special visceral efferent going for the muscles of facial expression and stapedius. Is that right? This is which nucleus? Motor nucleus of facial nerve or special visceral branchiomotor nucleus, if you want to be too impressive, right? Branchiomotor nucleus of the 7th nerve. Then it should be connected another motor output, that is parasympathetic motor output. This parasympathetic is going for salivary system mainly and lacrimatory system. So this nucleus from where this parasympathetic fibers are contributed to the facial nerve, this nucleus is called, yes please, what is this nucleus called? Superior salivatory nucleus. or it is also called lacrimatory nucleus. Of course, superior salivatory nucleus or lacrimatory nucleus is present at the level of lower pons because it is associated with seventh nerve. And seventh nerve is the internal special system into lower pons. Is that right? So seventh nerve, how many types of fibers you see? And of course, as I told you, seventh nerve is collecting taste sensation from anterior 2/3 of the tongue. So naturally, it must be connected with tractus solitarius nucleus. One more types of fibers are present in seventh nerve. Now I'm going to be impressed by one of you. Seventh nerve has one more type of fibers. These are sensory fibers. Sensory fibers from the ear. Touch, pain and temperature sensations from the ear go to many nerves, including some fibers go to the seventh nerve. Is that right? So these touch, pain and temperature fiber from the external ear, making them blue, right? They are going with the seventh nerve, and here they will, of course, they cannot end up into motor nuclei of the seventh nerve. They cannot end up into salivatory and lacrimatory nucleus, which is parasympathetic outflow. And this pain and temperature fibers, touch, pain, temperature fibers coming from external ear, of course, cannot end up into taste system. They have to end up into some nuclear system in the brain stem, which is related with touch, pain and temperature and pressure of the head and neck. The major system is trigeminal system. What is the major system? Trigeminal system. Now let me draw a diagram just to put the things again into more clear concept. Actually, let me draw a very simple diagram to show you the trigeminal system. Pons, pons, medulla, medulla, spinal cord, right? Now look, the principal sensory nucleus of trigeminal system is in mid-pontine area. So principal sensory nucleus of trigeminal cannot be seen at lower pontine section. Is that right? But from just below the principal sensory nucleus of trigeminal system, there is another nucleus here. What is this nucleus of trigeminal system? Yeah, spinal nucleus of trigeminal system, right? It is extending from the middle of the pons downward up to the upper spinal cord, upper cervical spinal cord. So this spinal nucleus of trigeminal system can be seen in the lower section of the pons and in all the sections of medulla. But in upper pontine section, you will not find the spinal nucleus of trigeminal system. You will only find the, what is this? Principal sensory nucleus of the trigeminal system. And then from here, what is this? This is a very special type of trigeminal nucleus. This trigeminal nucleus, which is moving from upward from the principal pontine trigeminal sensory nucleus, this is called, because it is going to the midbrain, so it is called mesencephalic nucleus of trigeminal system. So trigeminal system has how many nucleus? Number one, it has, what is this nucleus, please? Principal sensory nucleus of trigeminal. Then this is which is dangling down up to the upper spinal cord is called, yes, spinal nucleus of trigeminal system. And what is this, my friends? Mesencephalic, because mesencephalic means midbrain. It is extending up to the midbrain. Mesencephalic nucleus of trigeminal system. And few words. From the face, all the many sensations are coming to the trigeminal system. From the face, fine touch and 2-point discrimination, fine touch and 2-point discrimination come to where? Principal pontine. So principal pontine is nucleus is principal pontine sensory nucleus of trigeminal system is receiving fine touch from the from the face, and pain and temperature from the face, pain and temperature fibers from the face through the trigeminal nerve, they go down into, what is it? This is pain and temperature fiber from the face going to the spinal nucleus or trigeminal, and proprioceptive fibers from the face, fibers from the muscle spindles and the muscles of mastication and pressure fibers, all those are going to, what is this? Mesencephalic nucleus. Why I want to tell you this thing? Because later on you will learn that if there is lesion in the mid-pontine area, fine touch will be lost from the face, but pain and temperature may be spared. Or if there is damage to the upper medulla, pain and temperature from the face may be lost, but fine touch may be still there, intact. Am I clear, doctor? No problem? You are hearing me or just looking at me or the diagram? You are hearing me? Okay, that's very good. Your cochlear system is at work. Now, after having this concept in our mind, then lower pontine section will have a, what is this? Spinal nucleus or trigeminal, and upper pontine nucleus, upper pontine section will have principal nucleus of trigeminal system. And here it's worth mentioning, just medial to this, what is this? Motor nucleus of trigeminal, which gives the major output to the muscles of mastication. Muscles of mastication. Is that right? Now, after having said all of this, now we have to see the trigeminal. What is this now here? Nucleus of, which nucleus of trigeminal system? Yeah, it is spinal nucleus of trigeminal. Is that right? And from the spinal nucleus of trigeminal system, these are facial nerve fibers which are connected to that. And which fibers of facial nerve are connected to that? Please, can you help me to figure out? Touch, pain and temperature coming from external ear. Actually, this is what I wanted, the concept in your mind, that touch, pain and temperature fibers from the ear go along with the 7th nerve and 9th nerve and 10th nerve and some other nerve. But right now we are concentrating facial nerve. Here I am showing 4 components, right? Facial nerve as motor fibers of muscle, the facial expression connected to the motor nucleus of facial nerve, branchiomotor nucleus of facial nerve. Then there are parasympathetic fibers which are for lacrymotory and salivatory system. They are connected with the superior salivatory nucleus which is in the inferior pontine area. Then there are taste fibers in the facial nerve from anterior 2/3 of the tongue. They are terminating into, connected with the nucleus of tractus solitarius. And then of course there are some sensory fibers, somatic sensory fiber like touch, pain and temperature in the facial nerve. They are connected with, what is this thing? Spinal nucleus of trigeminal. Any question here? So now you have learned the sixth nerve system as well as 7th nerve system at the lower pontine section. Now what is left? 8th nerve system, vestibulocochlear nerve. When we talk about vestibulocochlear system, then of course that is more lateral to that. As I told you that from the ear, vestibular fibers are coming and cochlear fibers are coming to the lower pons. And we have already discussed that here is, what is this here? What are these nuclei? Dorsal and ventral, which were contributing to, what was this? Trapezoid body. So this is which nerve coming place? Cochlear. Is that right? And here is which, or we can say cochlear component of vestibulocochlear nerve, 8th nerve. This we have already discussed, right? Cochlear system. Then we are left with the vestibular system. Vestibular fibers which are concerned with the balance are coming from the inner ear through the vestibular component of 8th cranial nerve. And these vestibular fibers will eventually go to vestibular nuclear complex. Now vestibular nuclear complex has superior vestibular nucleus, lateral vestibular nucleus, medial vestibular nucleus and inferior. Inferior nucleus is below this section, that is inferior to lower pontine section. It should be shown in upper medulla section, but these 3 nuclei of vestibular system can be seen over there. Am I clear? So this is also, what is this? Vestibular, superior vestibular nucleus, medial vestibular nucleus and lateral vestibular nucleus. And what are these fibers coming? Vestibular. And now I should improve my diagram here. You know why? Because in the floor of the fourth ventricle, we find lateral to the facial colliculus, what? Vestibular area. So vestibular area, this vestibular complex is just under this vestibular area. You remember from the last lecture? Right. Now, these were important things present in lower pontine section. Now, I will draw one of the most important thing in lower pontine section. Have you heard of the medial longitudinal fasciculus? Have you heard of it? Medial longitudinal fasciculus. Where is the medial longitudinal fasciculus and what it is doing? You should be able to correlate structure and function, because later on we'll talk about when lesions are produced in this area. What is, ma'am, the function of medial longitudinal fasciculus? Have you ever heard of this word? Of course you must have heard many times, but you never thought. Okay, let me tell you. I will draw a daughter diagram here. I think Pons has many daughter diagrams to explain the medial longitudinal fasciculus. None of you is clear about medial longitudinal fasciculus? You have heard of it or you have never even heard of it? You are having your hearing okay, but then you must have heard of it if you are studying the neuro. Right, listen. Again, this is what? Brainstem. Is that right? Now, in the brainstem, you know, there are many motor nuclei, but right now I am concentrating on third oculomotor nucleus. What is this? Fourth nucleus. And here is your friend, what is this? Yes, sixth nerve nucleus. You know, third, fourth and sixth nerve nuclei are concerned with movement of the eyes, because oculomotor, trochlear nerve and abducent nerve, all of these nerves supply the extraocular muscles, the muscles which are outside the ocular ball and which move the eyeball, right? For example, if I am looking on that side, both eyeballs there, this is the function of extraocular muscles. If I am moving eyeballs here or up or down, this is all the game of extraocular muscles which are controlled by third, fourth and sixth nerves. Am I clear? No problem. Now listen one thing. Let's suppose, okay, you come here. You want to have a break? Okay, let's have a break and then we'll continue because of a big system. Are you understanding or I'm teaching myself? Okay, just have a break for 15 minutes. So we were working on this diagram and we are going to develop a concept about medial longitudinal fasciculus, what it is. But before that, I would like to talk about your eyes. All of you know that you have two eyes. Am I right? Right? Okay, this is your eyeball here, this is your eyeball here. And now, this is a muscle which pulls the eyeball medially, right? This is called medial rectus. What is it? Medial rectus. It is not medial rectum. Medial rectus. And there is a muscle on the other side which moves the eyeball outward. This is called lateral rectus. Is that right? Now, actually, sixth nerve nucleus gave rise to abducent nerve, and abducent nerve is connected with, what is it? Lateral rectus. Yes, you are yourself intelligent. Lateral rectus. Is that right? Now look, attention please. If you want to suppose, I want one specimen. Can you come here? Just come rapidly. Now, this young man is coming here and we are going to look at his eye movement and we will see how the nuclei interplay. Right? Look to the camera. Right? Now look, he has two eyes and I ask him to look on that side. Now, when he is looking on that side, left eye is moving to the outside and right eye is moving inside. It means right now, left lateral rectus is working and right medial rectus is working. So it means whenever left, now you look at this diagram. He is moving eyeball like this and like this. Is that right? In this case, of course, he has a beautiful nose here. In this case, what is happening? That left eye is moving outward, abducting, and right eye is adducting because inward. And here there is activation of lateral rectus, and here there should be simultaneous activation of medial rectus. Is that right? Now look at it. If we want lateral rectus to be activated, if he is looking to the left side, both eyes move together. It is called conjugate movement of the eyeballs. Thank God human eyeballs move in a conjugate fashion. It's not like this, one is looking on the left and another looking on the right, or one eyeball is looking up and another is looking down. They move together. Right? Now, look, when we want, he is looking to the left side. Yes, please, you look to the camera and look to the left side now. When he is looking to the left side, it means left eye. Which one? This one? Yeah, left eye is activated, controlled by 6th nerve nucleus. 6th nerve nucleus is moving it abduction. That is why abducent nucleus. But at the same time, medial rectus should be activated simultaneously so that it moves inward. Now, medial rectus is controlled by a special, you can say, subnucleus of 3rd nerve. Medial rectus is controlled by 3rd nerve, oculomotor nerve. It means whenever left abducent nucleus is activated, left eye will move leftward, right? At the same time, we should activate 3rd nerve in such a way that right eye should also move leftward. So whenever left eye will abduct, right eye should adduct. Is that right? It means abducent nucleus and 3rd nerve should be connected with each other. So God has provided, nature has provided you with a very special type of interconnection system in between the nuclei. Right? So whenever left abducent nucleus is activated, right, through a special interconnection, we call it intercom between the nuclei of brainstem. Interconnections between the nuclei of brainstem. This pathway, whenever 6th nerve nucleus is activated, it immediately through this pathway activates the contralateral 3rd nerve nucleus, so that if one eye is abducting, immediately, simultaneously, other eye should adduct. Now, you look on the right side. Look to the camera and move your eyeballs right side. Now, lateral rectus on right side is activated and medial rectus on the left side. How it, this time, activation was 6th nucleus on the right side. So it, move it, abduction. But this should be connected with the subnucleus of the 3rd nerve. That nucleus of the 3rd nerve which controls the medial rectus. Now, in this way, what I wanted to tell you that many nuclei within the brainstem are connected with each other so they can have coordinated movement in the head and neck, especially the very coordinated conjugate movement of eyeballs. And this pathway is called medial longitudinal fasciculus. There is right medial longitudinal fasciculus. Why we call it medial? Because in the diagrams, look here, this is present very, very medially. This is medial longitudinal fasciculus. It's going up and connecting different. This is medial longitudinal fasciculus. It's going up and of course it's going down also and interconnect different nuclei. Because it is medially present, we call it medial, and because it is longitudinally present, we call it medial longitudinal fasciculus means bundle. So we say in the brainstem, in the medial position, there is a longitudinal bundle of fibers. They never knew what it was doing previously. Now they know that medial longitudinal fasciculus is concerned with interaction, concerned with the coordination of different motor nuclei in brainstem, especially coordinating third, fourth, sixth with vestibular apparatus. What is this? These are vestibular nuclei, and vestibular nuclei are also, of course, connected through this system. Is that right? And many other nuclei also. So what you really see, that medial longitudinal fasciculus is a internal communication system within the nuclei of brainstem. Am I clear? I think it's enough for today. Class dismissed. Welcome.